Hi there, and welcome back to the Complete C Sharp Masterclass. Today we'll be going over the practical aspect of best practices and look at some of the things we've covered in the theory, like solid, like dry, kiss, and so forth. So, first and foremost, if you want to get the latest code, all that you need to do is run the following command. So, this just takes a little bit of time to start up. Let's give it a sec. So this is git bash. So you just need to go say git fetch and git checkout 0 to hero dot best practices dot questions. So this should now go and pick up the newer changes that was there. So let's go and see how this looks. So then we can open up the solution. Okay, so we should see a couple of changes in here and so forth. So first and foremost, let's have a look at the best practices. In this module, we'll be having a look at solid. So let's just start the program up and basically see what it does. This is not set to currently start up, so let's just cancel build. Give it a sec. Okay, cool. There we go. So let's set this as the startup and then we'll just run it and then we'll dive straight into the solids module. So we'll see a couple of things here when this program runs. There's a couple of different items over here that's printed out. So yeah, let's jump into the solid specific module and see how these principles makes code easier to understand. Okay. So first up, we have an example for each one. So we'll go through single responsibility, then we'll go to open close, interface segregation, list of substitution, and dependency inversion. So let's jump into it. First, we'll have a look at an example of a violation of solid, and then we'll have a look at how we can fix that violation. So over here, we have an employee service and we have some sort of static data that we're storing employee service data about. And this is a violation because we can clearly see this class is doing more than what it's supposed to. It's storing information about the employee, such as their first name, their last name, their email, their salary. We're able to register an employee, and it also sends an email and so forth. So this is just a really bad practice to do. Like, a class should not have more than one responsibility. So we'll have a look at how to fix this. So here we're just creating the employee service and then we're registering this employee. So let's go back and have a look at how we can go now about fixing this violation. So first and foremost, we go and we create an employee class. And this employee class just stores the information about an employee. So that's the first thing that we do. We're splitting the tasks into each class one task or single responsibility. So I have an employee class. This stores the information about the employee, such as their ID, their first name, their last name, their email, their salary. And then what we have here is the email service, and the email service is just responsible for sending emails. And then over here we have now an employee service, and this employee service uses other services and repositories. So here we have a repository. So rather than storing the data in some sort of a static list, we have some sort of a store. In this case, we're calling it a repository. A repository often refers to some sort of a database access or some sort of data access layer. So in here, we're just creating a new instance of that employee repository. And every time we try to register that, we delegate that to one of the services that's there. This makes the code easier to read, easier to maintain. And again, we can see we can now go and just pass the information to the respective service that can use that data to do what it needs to do. So this is the power of using single responsibility. We should always try to write code in this way because it's easy to read, it's easy to understand. Other people understand what you're writing as well. And this is best practices. So whenever we try to write code, try to maintain a single responsibility per class. rather have multiple smaller classes and methods that implement the logic and the functionality to do this. So yeah, that's really it from a single responsibility. Again, we have the same functionality, and then this just runs it and registers the employee. So this is a really good way you can go about implementing single responsibility. You should always try to do that. If you see any classes doing more than one thing, rather extrapolate that functionality and put it in a second class that does just that, like what we did with the email over here and what we did with the saving of the functionality, or like saving the employee information. Rather save that in a separate place than do it in all in the same place. So that's it from a single responsibility perspective. Let's now go back and have a look at how, let's see. So next up we have open and close. So let's see how this often is violated, and let's have a look at how we can go about fixing that violation and building better structured code. Okay, so over here we have some sort of a discount service, and we have a product with a name, a price, and a type. And then we build up this service, so we have a list of products, and we're trying to calculate what sort of discount each of these has. So we do this now by having some sort of a discount service, but in the discount service, we basically just checking, is this electronic? Is this a product of clothing? And depending on what product it is, we then calculate that specific discount. Now this is fine, but what happens if we have maybe 3 or 4 or 5 other types? We're going to have a list of a lot of if statements or even switch statements that we would now have to go and deal with to calculate the different kinds of discounts. This makes the code really difficult to read and very unmaintainable. So let's see how we can now go about fixing this violation example and what we can go and do with it. Okay. So this is the before, and then this is how we can go about fixing this. So first we create a type of product type, electronics, and then we create a discount calculator. This is a interface that is responsible for calculating the discount, right? And this interface says that it must declare, the implementer must declare what product it is. So here we have a type of electronics, and the electronics just calculates what discount it has. So here it's 10%, and it's of type electronics. Here we have a type of clothing, and we're calculating what the discount is for clothing. And then here we have a discount service now with a list of discount calculators. Now this is great because we can then just go say, hey, calculate the distance for this, which means we can just calculate whatever type of discount it is, irrespective of what type of item it is. And you can imagine how useful this could be if we have something like a cart. You know, if you're trying to implement something like a cart, and in the cart you have to have this type of item that basically goes and has this promotion, and the promotion only applies to certain products. Having something like this, we can then just, it doesn't actually matter. The code will just pick up the calculator automatically without having to add additional code and worrying about how the rest of the stuff works with us. So here we have an example. Let's see how we can extend this. So here we now go and say, okay, let's remove this. It's of type get, it's of type set. And then we need to add in another type here, our product type homeware. And this type over here is going to be homeware. So let's set this to homeware. Product type homeware. And now for this, we can set the same item here. We can copy this, and then we'll just set this over here for 15%. So we're having a sale. It's 15% on homeware for homeware. So previously we had these different types. So let's go and add in a new product in here. And in this new product, we're just going to say maybe a chair. And the price can maybe be, I don't know, 500 Rand. And the type will be product type dot homeware. So now we've added in a new type here, and if we now go and see how this looks, so we can just run this quickly. So let's, before we do this, we'll just see what this item is. So let's run this quickly and see what it does at the moment. So if we go to the top over here, we should see here we have, let's say open close. So here we have an example of total discount 101, 101. But now the difference here is that in the first one, we're calculating each one depending on the type. So now if we have a homeware one, we should see that our discount is larger. Yeah, so here we see we got a discount of 176. And what's amazing about this is we never had to change the implementation of a discount server. So it makes the code much more open to extension but closed to modification. We could now go on and add in as many different type of discount calculators that we want. We could even hook this up to a database that reads up different pricings for each type and so forth, so that we could set it in each of the respective item to take in the discount. But these are just examples of how we can make code much more open to extension, but we don't have to modify it in order for it to be working, you know. So it's a really good way you can go about not violating code. In here we would have to go and modify the calculate discount, which actually has nothing to do with the discount calculation itself. It also makes the code much more difficult to read and difficult to maintain. This is also like what leads into design patterns. So this what we actually saw here right now is actually a type of design pattern, which is actually called a strategy pattern, where we can swap out the type at runtime irrespective of what it is. We can actually go into further other types if you want to calculate just one type of discount depending on this. So we could actually go say, hey, give us a type of discount calculator based on the product. So you could create a factory, and the factory could say, hey, it's a homeware, so give homeware discount calculator, etc., etc., and then calculate the discount based on that. But yeah, this is just another way that the power that gives us another tool in our toolbox, making our code much more easy to extend and not making it really stuck or to the glue. So yeah, that's it from an open close perspective. So next up, let's have a look at Liskov substitution. So we'll have a look at the violation, and then we'll have a look at the application afterwards. So here we have a bank account, right? This bank account is an abstract class. It has a balance, and we can deposit and withdraw money from this. Now, list of substitution says that base classes should be able, or derived classes should be able to be swapped out for parent classes without having to care about how the underlying functionality actually works. It shouldn't change the correctness by swapping it out. For example, if we have two different types of savings accounts. Both of these are bank accounts, so it shouldn't matter which bank account it is. We should just be able to use it as is without having to change the correctness of it. So let's see how this is implemented, right? We have this base bank account class. It's an abstract class with two abstract methods that need to be implemented by the inheriting classes. So here we go and we implement these classes by overriding them. So yeah, this is just something to bear in mind. If it's abstract, it needs to be overridden. This can also be the same with virtual as well. The only other difference is that with virtual, we override them. We don't actually need this override keyword here, if I'm not mistaken. Oh, you do. Yeah. But in any case, so here we have the savings account. We can deposit some money in here, and then we basically just add an interest rate. So we have 5% interest rate here, and when we withdraw from a bank account, there must be at least $100 in that bank account. So if it's not, then we can't actually go withdraw, and we'll get a message. If it is, it'll just withdraw from the balance. And the same goes for the tax-free savings account. Exactly the same item, but here there's no limit. We don't need $100 in your account. You can just withdraw up until you hit zero. But now we run into a problem here where if we have a fixed deposit account, and we can deposit money into this, but we can't actually withdraw money out of a fixed deposit account. So this is where we violate something like Liskov substitution, because we can no longer swap out the base class for that specific type. So what happens is here we run into an error message. So if we run this now, we should now go and see cannot withdraw, cannot withdraw. Yeah, we just physically can't withdraw an item from it, right? So these are different examples of what we're doing, and yeah, so let's have a look at how this is going to look if we go about, for example's sake, applying this. So rather than worrying about, here we have a bank account and we have a savings account, and this savings account is able to deposit and withdraw money, and we still have the same tax-free savings that can withdraw and deposit money, but now we have to create a specialized bank account type. So what this means is we can deposit and transfer money out of that account, but we can't necessarily withdraw it. So this is often what happens if you have like a banking app or something. You have specialized accounts that cannot actually do withdrawals, but they can do transfer between accounts. So this is how we can go about implementing something like that. So rather than worrying about physically withdrawing that money, we just gonna remove it from the balance, and then we're gonna deposit that money into the account that we're passing it to, thus fixing the violation of not having to worry about swapping out base classes. So this is something to bear in mind. Where possible, if we see that the base functionality of other entities or classes is no longer applicable and we can no longer swap them out, the right thing to do is to create a new type of base class, which is maybe a specialized type that only deals with that, but it can still communicate with the other types. So over here, we can just transfer the money out into, let's say, for example, a tax-free savings account. So this is a good way that we can go about like implementing something like this. So yeah, just something to bear in mind. It's list of substitution is a really great way that extends the functionality of polymorphism. So you can see here we have a bank account, and this is a savings account, this is a tax-free savings account, and then we have a specialized one, and we can just transfer to any type of bank account that implements the base class. So yeah, that's it for list of substitution. Let's see, next up should be interface segregation. So let's have a look at the example of a, not application, I think these are in the wrong folders. Let's just move this into the right folders. Let's leave it for now. Let's just fix it, it's fine. So over here, let's see what the problem is. So this example of, yeah, so this is a violation, and then this is the application. So let's have a look at the violation, right? So here we have, at the start, we have a violation of how interface segregation works. So here we have an interface of type machine. It can print a document, it can scan a document, and it can fax a document. We have different format types of a document: PDF, docx, which is like Word, and then we have Excel. The document has an ID, it has a name, it has a content, and it has a format type. Now here we have a multifunctioning printer that basically goes and can do all these different things. It can print out documents, it can scan documents, and it can fax documents, which is fine if we need something like that, but more often than not, we might need to split this functionality up for reusability, because there might be other services or other machines that can only scan something, or they can only print out something. Like, let's say a terminal. A terminal should be able to print out a document. It should be, then we could have something like a QR code scanner that can just scan documents, and we could just have a fax machine that can just fax stuff. All these functionalities should be able to be grouped into their own instances. But let's see how this is violated. So we have this implements all of this, and then we have some sort of a violation example that builds this. So here we have print a new document, scan a new document, fax a new document. Now let's see how we can fix this violation by rather splitting up this functionality into smaller components. So here we have again the same items. So we have a document, format type, and this document has exactly the same stuff, except it overrides the string now. And now we create a type of iPrinter, which is responsible for being able to print out items. We have an interface that's responsible for scanning something, so this is some scanning interface. And then lastly, we have some sort of an ifax interface, and each of these are responsible for being able to do one specific thing. And here we see we have multiple inheritance that implements three different interfaces for the behavior that it needs to be able to do for the same multifunctioning printer. So here we have a document, sample document PDF. We have an iPrinter which implements this, but it can only print out an item. Here we have a document, a new document that's docx, and we have a scanner and we just scan that document. And then we have another new document here, but here we just fax a document. Now, what's amazing about this is we're able to use the same multifunctioning printer for three different types of interfaces because all three of those interfaces are implemented in those items. So this is also a really great way for allowing us to separate and group functionality based on what we need. This is a very common use case, especially in like different libraries that you'll find, like Mediator. Sometimes we only need to get one of the interfaces to just use that specific functionality instead of the entire object that we don't actually need. So we shouldn't force clients to implement interfaces that they're not gonna need. So that's sort of how you can go about applying interface segregation and how it's often being used. And then lastly, we have dependency inversion. So let's have a look here of how we violate this example, and then we'll have a look at how we can fix this. So we're back to the product type, and now we have a product, we have a product service. And in this product service, we can basically just add products, remove products, update products, get products by an ID. We can save changes to the database, and we just display items in the menu. Now, this is okay because it sort of does the functionality and out of the box would work, but this is not really how you want to go about implementing something like this. Mainly because we're now depending on a low level module, which is some sort of a way that this is saved in a list or it could be saved in a file, but we directly accessing where this item is. So again, dependency inversion states that high level modules should not depend on low level modules. Both of them should depend on abstractions. So what's happening here now is if we wanted to test the servers, we would have to create a new list of products and then pass that product in there and then try to see if that would work. But this is not really the right way that we want to go about this. We want to be able to just go and set new different types and be able to add items as we need to. So here in this example, we simply just create the product service, a bunch of products, and then we add the products, save the changes, and display the changes. So let's run this and just see what it does at the moment. Okay, so here we can see changes saved to the database. So you can see all the products that we've added in here, brand new laptop, book, blah, 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 blah. No, I think it would be this one. Yeah, this is a violation example. So here we have the different items that are there. But now let's look at how we would fix this violation to rather depend on abstractions rather than on low level modules. So over here we have the same example, but now we have some sort of a repository, which is a place where we can save items to a certain place, whether that be a database or a file or wherever really, it doesn't actually matter. And then we have a product service, and this product service basically takes in the repository. So as we can see, it takes in iProduct repository, which is any type that implements the interface of iProduct repository. And then the product service can now just do what it needs to do. It doesn't necessarily care about how the items work, it just goes about displaying them. So if we look at how this looks, we have this iProduct interface. So let's just peek how this definition looks. So here we have an interface that says we need to be able to add a product, remove a product, update a product, get a product by ID, and display the product's menu. So what happens here is we can now go say, okay, here's a repository, add a product, and save the changes. Display the menu by getting all the products from the repository or the store, and then loop through each of those products and display them. And then here we have get product by ID, which just gets that product by the ID. It can remove the product, it can update the product, and so forth, which is a really awesome way that we can now go about depending on a interface rather than a concrete implementation. So we can now go swap this out for any type. So it could be a list to fake this functionality. It can be really whatever we need to in order for us to implement this functionality and make it easy to test the services themselves. I'm a really big fan of this, and later onwards in the design patterns, this is an early introduction to design patterns with a repository pattern. We'll have a look at a more complex repository pattern, like a generic one, and see how we can go about benefiting from something like this, and then take it from there. So now we can just go and see how this looks in the example of how we go and fix this. So we have a list of products. We go and create the repository, and let's just have a look at how this repository looks. Again, it's just a list. This can take in an input of type list. And again, it's pretty much very similar code: adding, removing, updating, getting the product, saving the changes, and getting all the product. But the difference here is it's hidden behind a level of abstraction that we can swap out for any other thing. So if we had a database, or if we had a file where we're reading the products from, the product repository would be able to just work out of the box. So we could easily go and extend the same functionality without a lot of work, without having to refactor. Again, it does also follow that open to extension but close to modification. It just works. That's the best part about following solid principles and design patterns. Things just work. So yeah, then we have this product repository, we pass it into the service, and then we display the products. We go and update a product, and then we display the product, add a product, and so forth. So this is really the power of using something like dependency inversion, because we can go and simply swap out different implementations for this, and it will just work. We don't have to care about the specifics of the implementations of how some of these things work. It's a really good way that we can go about reducing code, that we don't need to write a lot of repetitive code. We keep our code clean, easy to understand, and straight to the point. So that's it from the dependency inversion aspect for this example, and that wraps up solid. So join me in the next example. In the next module, we'll have a look at the next item on the list, and we'll look at how we can implement some really cool code, clean coding, following dry, and so forth. So I'll see you in the next module.